Okay, today we are going to talk about calculating the area of a circle, sector of a circle, and segment of a circle. So just a refresher, here's your formula for area of a circle. Here's your formula for a sector. So remember the x stands for the degree of the arc that goes along with the angle you're trying to find, or the sector that you're trying to find. Okay, so let's jump into some examples. Okay. A segment of a circle is a region bounded by a chord of a circle and its corresponding arc. So here's our chord, and then here's the arc, and so like this would be the shaded region. What I would do to find that shaded region is I would create a triangle using the radii. I would find the area of the sector, and then subtract out the area of the triangle that goes along with it. So find the area of this whole sector and then subtract out the area of this triangle is how I would go about finding it. Okay, but first we're going to do some problems with circles. So let's talk about the area between two circles. So the area between two circles would be this area. So shaded region here. And to find this, much like if it were squares or rectangles, I would find the area of the big circle minus the area of the small circle. This is often referred to, or you might, like the book might refer to it as the annulus. So you might hear it referred to as the annulus. Oh, one U. But it's basically just the area between two circles is what we're calculating here. Okay, all right, so let's do some practice. So first one is area of a segment. So I'm going to go ahead and create a triangle. Okay, because I know that these are both 8. Okay. I can also, if this is 120 degrees, if I drop my altitude to find the height, it will bisect this angle, making that 60 degrees. So I've got a 30, 60, 90. So then if this is 8, that makes the height 4. And then it makes this 8 root 3. Okay. So now I can find the area. So I can use, like I could do base times height, if 1/2 base times height if I wanted to, or, well, I guess that would probably be the only way to do it. So let's find the area of our sector. So that's 120 degrees out of 360 times 64 pi, because the radius is 8, so 64 pi. So I put this in my calculator and I simplified it, so 64/3 pi. Then let's find the area of the triangle. So that's 1/2 base, which is 16 root 3, this is the whole thing, times the height, which is 4. So multiply that out and we get 32 root 3. So I've got 64/3 pi minus 32 root 3 for the area there. Okay, all right, let's try another. So this one says to draw a circle of diameter 2 and then draw a ring that's 3 units thick around it. So a ring around it that is 3 units thick, and find the area between the 2 circles. So I'm going to find the area of the big circle. I'm going to find the area of the small circle, and I'm going to subtract them. So let's keep in mind that this was 3, this was 2. So the area of the big circle has a radius of 5, so that's that's 25 pi. And then the small circle has a oh shoot, this says diameter. Good grief. Okay, so it's at a diameter of 2, which means that this is 1, and then 3 units thick, so that's still 3. So this actually should be 16. So this has a radius of 4, so that's 16 pi. And then the small circle has a radius of 1, so that's just pi. Or 1 squared is 1, so that's 16 pi minus pi makes 15 pi. So there's the area of the shaded region. So pay close attention to the wording, unlike me. So the diameter was 2, which makes the radius 1. So be careful with what they give you. Okay. All right, let's try another. All right, so find the area of the shaded region. So I don't know if you can see or if it's darkened in, but this is the area of the shaded region. So that is essentially a sector, but I need an arc length. Well, I know that if this is 50, that this is 100 degrees. And then it says the diameter is 18, which makes my radius 9. So area of the sector would be 100 over 360 times r squared, so 9 squared pi. So I put this in my calculator and reduced it and got 45 over 2 pi. Okay. All right, next one. So this one says find the circumference of a circle with area 24 pi. So let's see. So 24 pi is equal to our area, which is that. So if I divide by pi, they will reduce to 1. So I've got r squared equals 24 square root, and simplify, and I get 2 root 6. So now that's the radius. If I want the diameter, I would times this by 2. So then our circumference is 4 pi root 6. So knowing that if I'm going to find the circumference, I need the radius first is probably what you need to look for. What are you missing? What do you have? What do you need? Okay. All right, let's try this one. So this one says find the area of the shaded region. Well, if you pay kind of close attention to what these end up, so this says that it's an equilateral triangle, so that makes all of these 60. Okay, so essentially these 3 corners make half a circle. Or, well, yes. I mean, they will make half. They will, together, if you put them together, so if you take these and you make these your center, okay, and you draw a 60-degree angle here, and you draw a 60-degree angle here, and you draw a 60-degree angle here, these 3 corners essentially make a semicircle. So what I'm going to do is I'm going to find the area of the semicircle. Well, I'm going to find the area of the triangle, and then I'm going to subtract out a semicircle. So I'm going to find the area of the semicircle. So let's start with the area of the triangle. So since it's equilateral, I can use my formula of a side squared over 4 times root 3. So that 64 divided by 4 is 16 root 3. Then I'm going to find the area of the semicircle. So this is, since these are congruent, I have a radius of 4. So that's 16 pi for the area of the whole circle, but I want half of it. So that's 8 pi. So I'm going to take the area of my triangle and subtract out the area of my semicircle. Okay, let's try another one. Okay, so on this one, we're finding the area of the shaded region. So again, you have to think about if this is a square, okay, these are all 4 right angles. So together, these make a half a circle, and these make another half. So you're essentially taking a square and cutting out a circle. So let's find the area of the square. Let's find the area of the circle, and we'll subtract them. So area of the square is 12 times 12, so that's 144. Area of the circle, so this is 6, so that's 36 pi. So 144 minus 36 pi. Okay. Okay, last one. All right, so here's our regular polygon, or this is a pentagon. So for this one, I'm going to find the area of the pentagon, and then I'm going to subtract out the area of the circle. So let's refresh our memory. Find the area of the shaded region round to the nearest tenth. I think something got cut out of here because I should have a 17 here. Okay, so that I can get my perimeter. If I know my perimeter is 17, so that's 17 times 5 is 85, and then I need the apothem. So let's see, 360 divided by 5 is 72, so this is a 36, so I'm just going to redraw it. So I'm going to have to do trig. So this is 8.5. I can make it a decimal because I'm going to use trig anyway. So that's tangent 36 equals 8.5 over x times by x. So I got 11.7 for my apothem. So let's see. And the apothem is also the radius of my circle here. So let's see, I've got the area of our pentagon, so 1/2 85 times 11.7, which is 497.25. Area of the circle is 11.7 squared pi. Now since it said to round, I'm just going to get a decimal. Okay, and then I'm going to subtract them. So I got 67.42. Okay, so that's it. You've got homework down here, 1 through 11 for day 1, and then we'll spend a little bit more time on this tomorrow. So bring some questions over the homework.